Hey guys, in this tutorial for NodeCanvas, I'm going to cover setting up NodeCanvas, the different modules it provides, and how to seamlessly integrate those modules together. And we're going to set up some really basic, but hopefully fun scenario. I'm not going to go super deep into any of the modules at this point. I just want to show an overview of all and show you how they seamlessly connect together to make a really great and intuitive workflow. So to import NodeCanvas, we are going to open the package manager. Make sure we're looking at packages My Assets. Find NodeCanvas here. Download if you haven't already, and then import. And now you see we have our folder here, Paradox Notion, and inside there, Canvas Core and NodeCanvas. So there are three main modules in NodeCanvas. There's behavior trees, there's finite state machines, and there are dialog trees. In order to start creating one of these, all we need to do is create a new game object in the scene. Let's call this one Behaviour Tree. We'll make a copy of that and we'll call that one Finite State Machine. And the final one, which is called our Dialog Tree. So all we have to do is click Add Component. I'm going to search for Behaviour Tree and add a Behaviour Tree owner. We search for an FSM owner. And for dialog tree, we search for a dialog tree controller. And you can see these icons here. These three node looking icons means that you have added the correct owner or controller. And what we can do is we can create a new behavior tree by clicking this button here. And we're going to choose bound. So bound means it's going to be saved in the scene. Asset means it's going to be saved as an asset. For now, we're going to do bound. And this will open up this canvas here. In order to start adding nodes to your behavior tree, all you need to do is press right-click or press the spacebar. This is going to come up with a list of all the different nodes that you can add, along with helpful tips on what they're used for, as well as categories so that you can very easily find the nodes that you need. So to start with, let's just add an action. So spacebar, press action, and put that in. Now you see we have this little start tag up here, and that means this is where the behavior tree is going to enter. If I create another action and I right click it, I can set the start to be on that one instead. In this case, I'm just going to use this one here. So now that we have this node, when we select it, you can see up here, we have a little inspector. So this is where we set up the actions that this is actually going to do, the behavior that this action can do. So here I can press Assign Action Task, and that's going to come up with another list of all the different things we can do. So for example, we go into Utility, and I will choose Debug Log, Hello World. Okay, so we're going to log Hello World, and the seconds to run here is how many seconds this action takes to run. So once it enters here, it's going to do the action, and then after 1 second, it's going to return finished as a success. So every node has to finish with a failure or a success. So if we run the game, you can see every second it's logging hello world. So the good thing is that we don't have to just stick with debug logging things. We can actually get some more exciting action happening. So NodeCanvas comes with a bunch of action tasks. So let's get rid of the debug log by right-clicking, delete, and let's assign a different action task. We're going to look at movement, pathfinding, and we're going to choose seek, and there we go. So now here you see our parameters target, speed, and keep distance. The target is going to be something that we can assign outside. So let's set up our scene. So we have our blank scene here. I'm going to create a plane. Then I'm going to create our main character. So I'm going to make a cube. And let's call him character. And what I'm going to do is I'm going to put that character underneath that behavior tree. So the behavior tree is the root, and we have our character inside here, who's basically the visual part of that. And I'll create a sphere, and this is going to be our target. So we'll call that target. And all we need to do is click the node, and in the inspector, drag the target directly into there. And now it's going to seek that target. So importantly, what you need to do in order for this to work is you need to make sure the Unity AI package is installed, the AI navigation package. So just go into the packages, search the Unity registry, AI navigation, and make sure that exists. And once that exists, you can go in and you can add a nav mesh. So we're going to add a nav mesh surface to our plane here. We're going to put it on a nav mesh layer. We're going to add a few obstacles, just like that. Then we're going to click our behavior tree. So we want to click the root, not the inside character. And we're going to add a nav mesh agent. That looks fine. Now, let's just organize these a little bit. Make a scene folder, and I'll put all of these obstacles and the plane inside like that, and make sure they're all on the nav mesh layer. Then I will click bake, and we have a nice nav mesh like that. We need to make sure that we tell our nav mesh to only include the nav mesh layers like that. And bake again. There we go. So now we have a nice clean nav mesh, and we're ready to use our behavior tree. All right, so let's run the game and see what happens. All right, so you see as we move our target, our character is following, it's seeking that target. Just like that. But obviously this is not very smart AI, and would rather it acts a little bit more intelligently. So let's set up some basic conditions and some additional actions that it can do based on different conditions. All right, so what we want to do is we want to select a behavior depending on a condition. So we're going to add a selector composite. Right click and make sure that's our start, because we want our behavior tree to start from here. Now we have our action here, seek. Let's make another action. So right click, action, and we're going to search for patrol. All right, patrol mode random is okay. And let's assign our patrol points. So I'm going to press create. So now we have our target list, and I can just drag these into the target list. And in fact, I can grab multiple at once and drop them. And there we go. Our patrol points are set up. They're referenced in our patrol action task. So now our selector needs to go through a condition in order to choose whether to seek or to patrol. So for this, we're going to add a condition decorator. So we create a conditional decorator here. And inside the conditional inspector, we're going to assign a condition task, and that's going to be can see target. All right, and now if we click the can see target with our behavior tree object selected, we can see these gizmos, and that's going to help us adjust the parameters of the see condition. So let's say max distance 10, awareness distance maybe 5. So let's make this a bit bigger. So 15 for the max distance of being able to see the target, and awareness distance of 5. So if the target is within here, it doesn't matter the view distance or the view angle, it will always return true. And let's drag the target there as well, so the player. And now, importantly, right now, our raycast is directly on the ground, and that's going to cause us issues. So we want to just move it up. So I'm going to set an offset of 0.5. Okay, good. So now all we need to do is connect them together. So I'll just drag this from our selector into our can see target condition task, and then can see target will move on to seek, and then we will add patrol here. So what it's going to do, it's going to enter here, it's going to evaluate this condition. If that condition fails, then it's going to run patrol. So let's see what happens. Okay, so he can see the target. So he comes towards me and he finishes like that. Now you see, the problem here is that the can see target is not being reevaluated. And let's show the opposite case as well. So let's move our enemy behind here so he can't see me at the beginning. So he can't see me, therefore he's going to patrol. But if I move within distance of him, he still does not detect that he can see the player. So even if I move myself in front of him, he doesn't see that he can see me until he finishes that patrol, which is not really what we want. We don't want him to finish the patrol before he reevaluates seeing the target. And so for that, we can make use of the dynamic option. So when we tick this, it means that even while this is running, it's going to reevaluate the children. So it's going to reevaluate can see target, and then it's going to seek if it can, and it's going to patrol if it can't. So even if it's in patrol. And what we also want to do is set the can see target to be dynamic as well, so that it can break out of the seek. So both of these are going to be dynamic. So now he's patrolling. I move the player close enough. Now he's seeking the player. I move the player outside, and he will move back to patrol instantly. So what we can also do is we can add multiple action tasks into the same action. So in this case, when I can see the target, I want him to log something. So I'm going to say debug log, and I'm going to say stop right there. And what's quite cool is that we can actually show that as a label above that character. So let me just move my camera. Okay, so what he's going to do, and I'll just reorganize this, so I can just drag this to reorganize. So what he's actually going to do is he's going to say stop right there, then he's going to seek. So we can see he's patrolling here. Then he sees me, says stop right there, and then he runs towards me like that. So this is really useful for debugging what your behavior is actually doing, and eventually you can replace that log with an actual bark from the enemy or something like that. Now, just a note, he did stop for 1 second when he did that, and that's because we have this here, seconds to run 1. So next I want to have a look at our Blackboard variables here. So what we can do is we could add a variable to our enemy. So I'm going to make a float, and this is going to be called speed. Let's say patrol speed, and let's make one for seek speed as well. All right, so he's going to seek a lot faster. So I can click my action node, and inside seek, where I have the speed, I can click this little icon here, and I can connect that up to my seek speed like this. And I can do the same for patrol, speed, patrol speed. And now if you look at the enemy here, he actually has these exposed, and I can change those in real time. So if I play the game, all right, so I'll play the game, I'll disable the player for now, so he's just patrolling. All right, so I can change that patrol speed to be faster. But one thing you have to remember is that while he's running that patrol, he's running it at the speed that it started with. And at the end of that patrol, he will, if he's going to patrol again, apply that speed to that next patrol. You see here, elapsed time. Now he started the next one, it's at 5 speed, and I change it to 20 speed. He finishes that, and he moves a lot faster. So you can use these kind of variables, and I could make multiple versions of this enemy, and I could have them have different speeds. So this guy is quite good at patrolling, but bad at chasing. And this guy is just bad at both. All right, and to finish off our behavior tree simple example, what we want to do is we want to make sure that the enemy stops seeking when they're within a range of the player. So to do this, what we want to do is we want to add another selector, but we're going to add the selector later down in the tree. So I will just search for a selector, then I will delete that link just by clicking it and pressing delete. And I want this to go into here. And I want to create another action, and that's going to be just a log. and they're going to say, I've got you now. Okay, and we'll just run that for 3 seconds. Connect our dynamic conditional to this. And remember, we also want to make this dynamic, and we want to create another one of these conditionals. So we'll create a conditional decorator, connect that there, put that into our sequence, and we want to create a target within distance. So what we want is to say, if it's greater than 5, well, let's do 3. If it's greater than 3, they're going to seek. So they're going to say stop right there, and they're going to seek. But if it is less than 3, then they're going to no longer seek, and they're just going to stop. And because that's dynamic, if they're halfway through a seek and the distance changes, then they will stop that seek, and everything should work just fine. So let's see that in action and make sure we assign our player. And what we can actually do is make use of our Blackboard variables again by adding a variable. So we'll add a new game object, and we'll just call that player, and I'll drag in my player there. I'm just going to delete these other enemies. I'm just going to look at one again. Okay, so now we have that player, and instead of assigning it every time, we're going to assign it via the graph. And let's just call that target actually. So we have our target there, and our target here. So now we have our variable used instead of having to assign it to our scene object all the time. So that looks good. All right, and just make sure that we tag this as well, our target within distance, as dynamic so that it will stop correctly. And now we see he's going to patrol. He sees the player, says stop right there, runs towards him, it's within range, says I've got you now. And if we remove our player, he goes back to patrolling. No problem. And he sees the player again, and again goes in there. Perfect. So let's have a look at finite state machines. So to make a finite state machine, we're just going to add a component, and we're going to add it on the same enemy. So I'm going to look for FSM and add an FSM owner, finite state machine owner. I'm just going to put that up here. In fact, I'm going to drag my Blackboard up to the top like this. And I'm going to create a new FSM, making it bound, press edit FSM, and I get a very similar looking window to the behavior tree. However, this works differently to the behavior tree. The finite state machine keeps everything inside states. So while I'm in this state, these actions are going to happen. And when I enter this state, other actions are going to happen. So for example, let's make a state called alive and a state called dead. Now what you'll notice is that when I open my Blackboard variables, all the variables from the behavior tree are also available inside here. And that's because we saved them in the enemy Blackboard variables. Variables that are saved here are saved on the object and can be accessed via behavior trees or finite state machines. If I add a variable to this graph here, then it can only be accessed inside this graph. So for example, if I added a Boolean here, and then I opened up my behavior tree, I don't have access to that because that belongs to the graph here. All right, but this is very useful because we can now actually adjust variables within our behavior tree or within our finite state machine. So let's add a new variable called HP, and let's make that 5. So I have this action state alive. We're going to start in alive, and if my HP becomes 0 or less, so we create a condition task here, we search for check int, we connect that to our HP variable here. And if this is less than or equal to 0, then we're going to move into our dead state. And what I'm going to do actually is I'm going to change the color of our enemy depending on whether they're alive or dead. So here I'm going to assign an action task, and I'm going to look for set property. And what set property allows us to do is it allows us to find properties on any object that we put in. So right now it's on ourself, but we actually want to put it on our visual element here, our character. So I'll drag that character in there, then click select property. I have access to all the components on my object. And I'm going to choose my renderer, and I'm going to look for set material. So in alive, I'm going to set the material to be red, and I'm going to right click this and copy, go to dead, assign action task, and you see down here, I can actually just press paste and then change this red for gray. So when my HP goes down to 0 or below, then I will be set to dead. All right, and let's just turn off that behavior tree for now and play. All right, so you see here, we're in the alive state. It's checking the integer for HP. HP is greater than 0, and so it is failing that condition, therefore it is not transitioning to dead. Now if I change the HP here, 0. And it has been put into the dead state, and the dead state has no conditions to check, and so it's finished. And you see our cube here has changed to gray. So that's working great, but I actually want my finite state machine and my behavior tree to coexist. And right now, if I play, and I change the HP to 0, he's still doing the behavior, even though he's technically marked as dead. So what's really great is that we can actually create a state which runs a behavior tree. So the first thing I'm going to do is I'm going to go into my behavior tree. So I have my behavior tree here, and I'm going to say edit and save to asset. And I'm going to call this my seek behavior tree, or maybe let's call it the aggressive behavior tree. Okay, so now I have an asset here. And if I click this, it opens up the behavior tree. And as you can see, all these variables are actually disconnected. But that's not a problem because we're going to be using it on this object here, where all those variables are set up correctly. So first I'm going to delete this component here, the behavior tree owner. So now we just have our finite state machine owner. I'm going to edit this, spacebar, subgraphs, and I'm going to create a sub behavior tree. Now we've already created an asset, so we can drag that aggressive behavior tree into there like that. Then I'm going to copy paste this. So we have two of these. I'm going to call this one aggressive, and I'm going to call this one intimidated. So we have these two states, aggressive, intimidated. Then we have dead. And actually the alive state, I'm just going to call that enter. Then what we can do is make use of some additional features of our finite state machine. So what we want to do is we want to have aggressive can change to be intimidated. So we drag this here. And what I'm going to do is I'm just going to create some variables here. So create a Boolean for intimidated. Okay. So then here we're going to check Boolean. We're going to check our intimidated variable. And if we are intimidated, then we're going to move to intimidated, and then we're going to do the opposite here. So here, if we're not intimidated, then we're going to go into the aggressive tree, and we're going to start off here as aggressive. So it's going to enter, set that property, then immediately go to aggressive. Then if our intimidated turns on, it's going to be intimidated. And if intimidated turns off, it's going to go back to aggressive. Then from any state, so we can create an any state, drag that into there, and assign a condition task for int. So check int, and we're going to do what we did before, where we check the HP is less than or equal to 0, then he's going to go into the dead state. So what I'm going to do is I'm going to copy paste my aggressive behavior tree and call this one intimidated behavior tree. And now what we can do inside NodeCanvas is we can actually traverse through the hierarchy of our entire graph. So for example, intimidated, I'm going to set, so aggressive is set to be aggressive behavior tree, but I want to set intimidated to be the intimidated behavior tree. All right, so we have the intimidated behavior tree and the aggressive behavior tree, and we can go into the intimidated behavior tree and we can just change our seek to be a flee. So I'm going to add an action task, search for flee. We're going to flee from our target, and we're going to delete that seek. And then the log is going to say help instead. And we will just connect that speed up with the seek speed. So if they can see the target, and the target is, and we're going to change this to be less than, let's say less than 8, then we're going to flee as far away as possible, well, to 15. And we don't need this actually, and we don't need this. So what we can do is we can actually combine these two. So to do that, I'm going to right click the target within distance, copy it, go into here, assign condition task, and again, I can just paste that there very conveniently. So if all of these are true, if they can see the target and the target is within distance, so less than 8, then he's going to say help and he's going to flee. So What's really great is that I can go back up my tree by clicking this here. So I have my FSM, double click into aggressive. This looks fine. Double click into intimidated. Our new tree, that looks fine. Everything looks good. Okay, so let's run and see what happens. All right, so we're in the aggressive tree. I'll double click. We're patrolling. He sees the target. He goes towards him. Great, that's all working. Now, let's say our player does something to intimidate the enemy. So I'll turn that on. Help. Now he is run away and he's gone back to patrolling. And if he gets close to the player again, he will run away again. All right, and now let's kill him. So we set his HP to 0 and he has died. So let's go back up here. You see he's now in dead. He's gray and he's no longer running the behavior trees. So it's very nicely managed, very easy to read, very modular, very easy to iterate on. So this is a great advantage of NodeCanvas. Everything seamlessly works together. Great, so now we have our behavior trees and our finite state machines with a basic overview done and how they kind of work together to make really easy AI design. So let's look at the last component, the dialogue trees. So the first thing I'm going to do is I'm going to bring in the @dialog UI. So I'm going to drag that into the scene, and that's going to give me the UI required to show the dialogue to the player. So you can always implement your own, but for the tutorial, we're just going to stick to the default one. All right, so now we have that. And what we're going to do is we're going to add onto our enemy a dialogue actor, and his name is enemy. That's fine. Now what we can do is we can create an action task here. So after we set the property, I'm going to have him say something. So you can just say, and in this case, I'm not going to use the dialogue tree right now. I'm just going to show you this. Hello, I'm an enemy. We need to make sure that we have an input module. So just add a standalone input module here. Good. So now when he starts, he's going to say his dialogue, and you see it's going to wait for that to finish before it goes on. Then he goes into the aggressive stance. Stop right there. I've got you now. Intimidated. Help. And he runs away and he goes back to patrolling. So we can put that dialogue anywhere. It can be within the state like we have here. We could also put it inside here. So for example, here, when we debug log stop right there, instead of the debug log, we can do say, and we'll just do a say random actually. So here you'll say stop, halt, don't move, and we'll get rid of that debug log and make sure that the say random happens above. All right, and now we'll run it again. Hello, I'm an enemy. Stop, and then he goes to me. I've got you now. All right, so now what I'm going to do is add a more complicated dialogue tree. So I'm going to select my enemy and I'm going to look for dialogue tree controller. So we add a dialogue tree controller here, and I can edit my dialogue tree by clicking this. So now we have our dialogue tree right here. And inside here, we're going to do a few things. So we're going to say, I've got you now. Then I'm going to do say. So we're going to choose a random option from these. So this one's going to say, you scoundrel. This one's going to say, you scumbag. And the last one's going to say, you jerk. So just random insults. So what I can do here is I can search for a probability selector, drag that in. You see it dynamically shifts the percentages, but you can also change the weight. So I could make him say, you scoundrel more often. And then we're going to converge back here where he says, what do you have to say for yourself? And let's make sure we connect that in there like that. Now we can use a multiple choice, connect that, and we can add choices. So in this case, I'm going to add a choice for I'm sorry, and then another one here for I'll kill you. What we want is when the player says I'll kill you, for the enemy to get intimidated. So everything's going to wrap nicely up. So here, I'm going to drag this out and I'm going to say, okay, here we go. So what you can see here is that this one has been assigned to I'll kill you. and this one has been assigned to I'm sorry. Now, what we can do is we can reorganize these. So I can just move this one down here, and now I'm sorry goes to this, which is going to be you better be. And then that's where we're going to end that dialogue. But if the player says, I'll kill you, then what I'm going to do here is I'm going to do set variable Boolean, and we're going to grab our intimidated, and we're going to set it to be true. So we have a basic dialogue tree with some random chance options as well as some player input options. And when I go back to my finite state machine, and remember it's inside the aggressive behavior tree, so we'll go into here, and instead of this debug log, I'll delete that, and I will create a dialogue tree, start dialogue tree. All right. Now, remember, we need to make sure that this goes through the variables. So we're going to do this, and we can actually just create a new one here. So we'll create a new one in the enemy, dialogue tree controller, and yes, we want to wait for this action to finish. And then inside here, we just make sure that we drag our dialogue tree controller up here. So now let's play and see what happens. So I'm going to go back up to the root level. Okay, so he's got his introduction dialogue. Cool. He enters this aggressive tree. He's patrolling. Says stop. Don't move. I've got you now. You jerk. What do you have to say for yourself? Player choice. I'll kill you. He gets intimidated and he runs away, and then he starts patrolling again. Great, so we've been able to integrate all three modules of NodeCanvas into a really basic project, but despite being basic and very quick to set up, we're able to get some pretty compelling behavior already. So hopefully this tutorial helped you get an overview of how NodeCanvas works, the different modules, and how powerfully and seamlessly it all integrates together to make designing your game much, much more enjoyable, much more intuitive, and much more modular and iterative.